Good morning, everyone. Hello, welcome, and thank you for joining us today for the Embodied Carbon Network's 2018 webinar series. This is the third session of an 8-part webinar series, and it will focus on embodied carbon emissions at the building level. We have several exciting speakers joining us today who will share their knowledge and insight on initiatives happening across the industry to quantify, track, and reduce emissions over the course of a building's life cycle. My name is Tina DeLeggi. I'm a program manager at the Carbon Leadership Forum, and I'll be moderating today's session. Please note that this webinar is being recorded and will be made publicly available upon its completion. A lot of you joining us today are already members of the Embodied Carbon Network, but we do have a number of people who are new or joining us as guests today, and we hope that you learn a little bit about our group today and consider joining us. The Embodied Carbon Network is a communications and knowledge sharing platform that was launched by the Carbon Leadership Forum about 1.5 years ago. The network brings together individuals working in or with the building sector together to share resources, engage in discussion, and organize to take action. The network has evolved into a vibrant, engaged global community. To date, we are over 280 professionals from across the building sector, academia, nonprofit, government groups, and we are now representing 90 cities across the world. So truly a global initiative we have here. Well, on the ground, for our members, a lot of our work might look a little bit different in terms of the research and development we're doing, tool building, education, and outreach. But at the network, we are all brought together under a shared mission to eliminate emissions from the built environment in order to meet carbon neutrality targets by 2050. The network has 9 subject-specific different task forces open to members to join. They can join as one or as many as they would like, and these are spaces for more focused engagement around a specific topic. So the Embodied Carbon Network was convened by the Carbon Leadership Forum. The Carbon Leadership Forum supports and manages the network, and it's an academic collaborative based out of the University of Washington that carries out research, education, and outreach focused on embodied carbon tracking and reduction. So thank you to the CLF and its sponsors for supporting the network and this webinar series. We'll hear more from its director, Kate Simonen, in a little bit and hear about some of the exciting work that the CLF has been working on. So again, today's session is the third of an 8-part 2018 series. Each topic is based off each of the task forces topics, and the task forces are working together to develop the curriculum and find some speakers and subject matter experts to come out today. The webinar series is part of our goal to increase knowledge and provide resources in the building sector. We have a lot of knowledge and expertise in our network, and this is just one of the many ways that we hope to kind of capture that and turn it around into a resource that people can go and use. So if you are an AIA member and in need of educational credits, this is eligible for live attendees to receive credit. Just follow up with me afterwards and I'll make sure you get that. Today's session, buildings, will include 5 presentations and a 10 to 15 minute Q&A session at the end. So if you have any questions for our presenters, please use the question function on GoTo. I'll be tracking these as we go, and then we'll save some time from about 10 to 10:15 to direct these questions to our speakers. So with that, I will turn over now to Ryan Zizzo, who is our buildings group chair. Ryan is the technical director at Zizzo Strategy, an interdisciplinary consultancy based in Toronto. Their team of lawyers, engineers, and green finance experts assist in public and private sector clients transition to a low carbon and climate adjusted future. As a professional engineer and green building expert, Ryan creates and implements sustainability strategies that help clients understand, track, and reduce their environmental impacts and exposure to climate risk. Strategies include green building certifications, embodied carbon life cycle assessment, and resiliency strategies. So Ryan, I will hand over to you now and let you kick off the session.
Great. Thanks very much, Tina, for setting this up and for introducing the day and the webinar. We are excited about the call and everyone on the line right now. So I'm just going to give a brief introduction of what is to come over the next 55 minutes roughly. So we are going to be joined by Kate Simonen, Megan Stringer, Caitlin Gillis, and Graham Twyford Millis. Sorry if I mispronounced any of those names, which I'm sure I did. I'll just give a brief introduction of what each of them will talk about, and then we'll go into the presentations. So Kate, we'll start with Kate by kicking us off with an update on the initiatives of the Carbon Leadership Forum, who's been pushing to the adoption of LCA in practice, and she'll reflect on some of the insights learned so far through her work, and particularly talk about some connections with the LEED green building system. Then Megan will share some information on a new document published by the American Society of Civil Engineers. The document's called Whole Building Lifecycle Assessment, Reference Building Structure and Strategies. So it's all about the reference building in the LEED credit. Megan helped develop this document as part of her participation in the Structural Engineering Institute Sustainability Committee. We'll then move it over to me, and I will give a brief presentation of a document by the Royal Institute of Chartered Surveyors. It's a new document that was released last year, and that's a group based in the UK. So I know quite a few of our members and those calling in are based in North America, and they may not be familiar with this document from the UK, so I thought it would be but it's a very high quality and useful document, so I wanted to make sure people were aware of that. So I'll give a brief overview of that, and then Caitlin will talk about the Canada Green Building Council's new green building standard, which is called the ZeroCarbon Building Standard, and it has a specific section and approach to embodied carbon reporting. So that will be interesting to see how that's developing in the Canadian market. And then finally, Graham will close out the webinar today. He will give us another Canadian example. It's actually a case study. It's Canada's tallest mass timber structure, and it's a building called Brock Commons at the University of British Columbia in Vancouver. So with that, I will give it back to Tina.
Great, thank you, Ryan. Okay, so Kate, I am going to go ahead and make you a panelist, and then I will introduce you. Okay. So Kate Simonen is founding director of the Carbon Leadership Forum, again, an industry academic collaboration highlighting the carbon impact of the built environment and developing pathways for carbon smart buildings to be part of the global climate solution. She is an associate professor at the University of Washington. She's a writer and a researcher with significant professional experience in high performance building systems, seismic design, and retrofitting, net zero energy residential construction, prefabrication, and collaborative practice. She authored the Authoritative Lifecycle Assessment and LCA Practice Guide and is co-chair of the Embodied Carbon Network, a global open access communications and action network. All right, so Kate, thank you for joining us today, and over to you now.
Thank you, Tina, and hello, everyone. I'm going to start off here with a brief overview of critical issues in whole building life cycle assessment and pointing out some resources that are available. And then I'm going to go into detail on one interesting challenge about implementing whole building LCA related to the LEED credit. So as Tina mentioned, through the work of the Carbon Leadership Forum, we have outreach work of the Embodied Carbon Network, as well as developing conventional academic research and more practice-focused documents. Specifically related to whole building life cycle assessment, we are nearly finished with the LCA Practice Guide, which is working to translate the specifics of global life cycle assessment standards to a more industry-specific introductory level. That will be published by June 1st of 2018, and current copies are available on the Carbon Leadership Forum website. Broadly, when conducting a whole building life cycle assessment, there are two numerical efforts. One is to estimate the inventory of materials, and I could say materials and energy in a building. So you're understanding the quantities of steel, glass, electricity consumed, natural gas consumed, such. So first you need to understand that inventory of materials, and then you're needing to multiply it by environmental impact. So an estimate of the environmental impact for each of these different processes. And then you're summing them up to get the estimate of the total environmental impact of a building. And so in that process, there are whole building LCA tools that help do both of those steps. So they help estimate the inventory of materials and include environmental impact estimates. And so that there's one category of LCA data that can be obtained with building industry specific tools. There's also LCA data available. So if you understood the quantities of materials yourself, so you had a bill of material quantities, you could multiply by impacts from a range of data sources, some free, some higher quality, some more transparent and easier to use. So in current North American practice, most architects and engineers are either using whole building LCA tools, Athena or Tally, or they are accessing open source LCA data from either environmental product declarations, the BAS inventory of carbon and energy, which is based in the UK, and the Quartz database of materials, which has both environmental and health impacts. And so which tool to use depends upon whether or not you already have material quantity information and what interface you're looking for to estimate those material quantities in your design workflow. So a major warning that should be noted is that the data is not comparable between tools or databases, or even between most environmental product declarations. So that doesn't mean that the data is bad. It just means that there are different assumptions that go into the framing of the data sets. And so you cannot take, say, data from Athena for one building analysis and compare it to another analysis from Tally and have comparable results. Similarly, picking and choosing data from different environmental product declarations, which for different material types also may not have comparable system boundaries, nor even the background data. So, so in the whole building lifecycle assessment, one major application that is happening is people working to get LEED credits in the LEED version 4. So the LEED version 4, the goal of getting the credits is to demonstrate that your project structure and enclosure have a minimum of a 10% reduction in at least 3 of the 6 impact categories commonly tracked. And one of them must be global warming potential. And that no impact category can increase by more than 5%. So there's some other details around that, but broadly speaking, you're asked to evaluate the proposed building, the building that you're planning to build, and compare it to a reference building and demonstrate this improvement. And so here I have a case study example in which a new design is compared to an old design in blue, normalized to 100% here. So the global warming potential or carbon footprint has almost a 33% reduction in the new design, but the ozone depletion potential has over 200% increase. And all the other environmental impacts, acidification, eutrophication, and smog formation potential all had at least a 25% reduction in this new design. And so in this project, it would not meet the LEED criteria because one of the impacts, ozone depletion, has more than a 5% increase. In fact, it has a 200% increase. And so the LEED rating system assumes all environmental impacts are equal effectively. And so this is one building example, but this issue has come up on a couple of other projects, and so we were wanting to dive into this and understand a little bit more of what's going on. So we did we took materials quantity databases, 2 of them, and normalized the impacts related to the emissions per person in the United States. So if the number here is high, it's a significant emission, and if the number is low, it's insignificant. So you can see here that ozone depletion potential is almost at 0. So for almost all, there's a couple of material impacts where it's not 0, but for almost all of the materials, the relative emissions are very small compared to the national emissions as a whole. You can see eutrophication is also fairly small. In another database of materials, we see a similar condition where, again, ozone depletion impacts are really insignificant for materials when compared to the relative impacts of the other environmental impacts. And this is not terribly surprising because ozone depletion emissions are primarily related to refrigerants and other processes that have been managed by the Montreal Protocol. So manufacturing processes that released ozone depleting chemicals have been put under control in the last 30 years or so. And so it's not surprising that there's very little emissions related to material production. Eutrophication potential is also not highly correlated with building material manufacturing because it's mostly related to fertilizers and nutrient flows. So one would expect that eutrophication may show up in some of the timber production in the Southeast where they use fertilizers and some other things, but it is less significant than the impacts that are related to fossil fuel consumption. So if we look at looking at this whole building life cycle assessment, shows that it's not LEED compliant. What should you do? Should you not make this change, which has a fairly significant reduction in many impacts because it has a high increase in another? We're putting together an argument that in the next iteration of LEED that we should not include ozone depletion in this criteria, because if you normalize the whole building results, again, you can see that the relative impact of ozone is very small. And so my recommendation would be that you don't use ozone depletion as a criteria to select building materials or in whole building life cycle assessment. But at the current time, that's not the case. So right now, you would not meet the LEED credit if your building had this occur. So in conclusion, I just want to highlight that whole building LCA is a learning process at this stage. And that although we are learning how to do it well, and we're learning how to compare and have benchmarks, and that I would encourage all people to approach the use of whole building life cycle assessment as an opportunity for you to ask questions and inform your practice, and also encourage you to share your data publicly so we can help advance the practice. So that is, I'm wrapping up and passing it back over to Tina.
Great, thank you so much, Kate. And just a note too to everybody, I will make sure to follow up with attendees after the webinar sometime early next week. And I'll make sure that you have a list of all of the links to the resources that are mentioned today. Okay, so we will be hearing now from Megan Stringer. So Megan, you should be able to share your screen. So Megan is going to tell us a little bit more about another guidance document that's going to be published shortly by the ASCE. Megan is a senior engineer at Holm Structures San Francisco office. She is their leading sustainable efforts and has been the project engineer on numerous large new commercial office and retail buildings. An active member in the sustainable design community, she has chaired the Structural Engineers Association of California's Sustainable Design Committee, and she is an active member of the ASCE Structural Engineering Institute's Sustainability Committee. She has been researching the environmental impacts of different structural systems, focusing on quantifying and reducing those impacts. She has presented at various conferences on sustainability and the role engineers have on shaping the built environment. All right, so Megan, take it away.
Thanks, Tina. So I'm excited to talk to you all today about this document I've been working on for the last couple years with the Structural Engineering Institute Sustainability Committee called Whole Building Lifecycle Assessment, Reference Building Structure and Strategies. So this document is going to be published later this year, and it's focusing on providing guidance on how to define the reference building within whole building LCA. So why do we create this document? Whole building LCA is recognized in LEED version 4, as well as green building standards such as the IGCC, CalGreen, and ASHRAE 189.1. These rating systems and standards require showing an improvement in environmental impacts when compared to a reference building using whole building LCA tools. While these rating systems and standards do often limit the assessment to just the structure and enclosure, I think this was particular to encourage structural engineers' participation. There is currently no existing standards or guides that provide enough specifics about the structural system and materials within the reference building, which could allow a project team to construct an unrealistic reference building that shows a false improvement in a proposed design. The committee felt this situation would fail to encourage meaningful contribution from the structural engineer and could lead to unfair rewards being given. So as such, the committee developed a guide that serves as a pre-standard for use by a project team to define and model the structural system within the reference building as required by green building standards and rating systems when performing comparative whole building LCA. So this document illustrates how project teams can make improvements to reduce environmental impacts through the project team's design and construction choices. The scope of this document is limited to the definition of the reference building design and construction choices within the influence of the structural engineer, and lastly, discussion of the approach to constructing the reference building design influenced by choice of structural system and materials. So this guide does not discuss the process of conducting a whole building LCA, or it doesn't compare the standards and rating systems that prescribe the use of whole building LCA. So this guide does also assume that the reader possesses a basic knowledge of life cycle assessment. So if you don't have this basic understanding of whole building LCA, there are resources listed in the document for you. And also the guide that Kate just previously mentioned will be another great resource for you. So talking about the guide itself, it is structured into two different parts. The first part sets out fundamental concepts to support a defensible reference building and includes definitions, reference building options, and general considerations to keep in mind when defining the reference building. The second part describes specific strategies for reference buildings that may be employed to reduce life cycle impacts on a project. Now, these strategies are not inclusive to all possible strategies that may prove effective in reducing the life cycle environmental impacts of a building, but rather they're strategies that the committee deem most common or effective and also are the most relevant to the role of the structural engineer. So the 9 strategies included in the document are listed up on the slide. Within these strategies, there is guidance on how to employ the specific strategies, examples are provided, any issues that you should be aware of are explained, and then if there are any material-specific considerations, they are discussed. So this section is definitely going to be a great resource, even if you're not performing an LCA on your building, or even if your project doesn't have sustainability goals. They're just great strategies that can be employed to design any building to have less environmental impacts. So this guide does aim to encourage structural engineers to take a more active and meaningful role in the practice of green building and life cycle assessment. And while the authors of the guide are structural engineers writing primarily for structural engineers, other building professionals will find value in the document. So a draft picture of the cover is shown up on the screen, as well as the website where you'll be able to order it. So the PDF of this guide is due to be published by ASC Publications in August, and the physical book will be available in September. So keep an eye out for this publication, and I guess if anyone has any further questions, feel free to email me.
Great,
so
thank you
turn it
so
back
much,
to Tina.
All right, thank you. And just a note too, I see some questions coming through, which are great. If you have questions, just send them to me through the GoToWebinar question function. And then at 10 o'clock, or as soon as the presentations are over, we will open up to the speakers to answer these questions. Okay, Ryan, so I'm going to make you presenter. So we're going to hear again from Ryan Zizzo. So Ryan, again, is a technical director at Zizzo Strategy and chair of the Embodied Carbon Networks Buildings Group. He has worked on over 50 green building and neighborhood projects with leading Canadian and European architects, developers, and property management firms, and has spent 3 years working in the leading Nordic green building scene in Helsinki, Finland. So Ryan is going to tell us a little bit more about carbon assessment guidance work happening in the UK. Over to you, Ryan.
Great, thanks very much. And so yeah, as mentioned, I'm going to be talking about a new guidance document that was published in the UK. It's called the Whole Life Carbon Assessment for the Built Environment. So this is what the cover page looks like. It's by the Royal Institute of Chartered Surveyors, referred to as RICS. And I just wanted to bring it to the attention of everyone on the webinar because, as I said, it's quite a high quality document. There was a lot of really good information and default values and guidance, which we'll go through a little bit in the following slides. And since it's not referenced in the LEED system or other places that many of the North American-based designers and engineers and architects would look at, I just wanted to make sure it was on the radar for those on the call from North America. So I have a bit of background here on the next two slides, and then I'll go into some screenshots from the actual document. But for RICS is a professional association for anyone who's not familiar, and they're typically cost consultants. So they in the UK, they are called upon when detailed costing of projects is going to be undertaken. And they realize that, you know, as embodied carbon and the carbon piece of material started to come up more and more in discussion, they realized that they actually were in a good position to provide guidance on that carbon of material, since they were the ones that had the best idea of quantities and estimations for material. So that's how a costing consulting organization kind of developed this guideline that is a little bit outside of their typical work, but it's very much related to it. This was a partnership that developing this document through a group called Innovate UK. So it came from government-funded research money, and they have a number of different focuses, one of which is buildings. This development of this involved a number of different players, from academia to contractors to LCA practitioners. And actually, one of the members of the Embodied Carbon Networks building group is one of the main authors on this document. So unfortunately, he was not able to join us today. He's based in the UK, so it's end of his day on a Friday. But we had a good chat about the document, and he gave me some of this background. So it was someone from the Arab company that was developing this document. So he's one of our members, which is good to know. There was a big push in the UK actually previously to have embodied carbon as something called an allowable solution in one of the proposed energy code updates, but that entire new code update for reducing carbon was kind of scrapped in one of the last elections because the government that ended up winning the election was running on a platform of reducing red tape, and they saw this as, you know, an additional layer of quote unquote red tape that developers had to go through, and it got tied up in the arguments in the UK of having a housing shortage, and they were trying to streamline and make it easier for developers to build construction, and this was seen as something that didn't quite fit that mandate that they ran under. So that was the background as to why so much background information was done and analysis was done and guidance documents were created, but then it ended up not being implemented. So there's a lot of great work that went into this that I think other jurisdictions can make use of. And a number of key projects in the UK are using this document and this guidance. One is HS2 High Speed Rail 2, which is one of the biggest infrastructure projects in Europe actually undergoing right now. So the document includes some mandatory requirements, which they refer to as musts, and also some voluntary requirements, which they use the word should. And anything that's in purple boxes in the document, which I'll show some examples, that's all must. That's all mandatory requirements. So anything purple is a requirement. They give a lot of good guidance in terms of what to be included, what building systems to be included. And they also have some mandatory requirements of which life cycle phases to include. One thing to note is that they specifically require operational energy use, which is the B6 life cycle phase, and that is specifically excluded in LEED and the Canada Green Building Council Zero Carbon Building Standard. So that's just something to flag that if North American users are trying to do a model in compliance with LEED or the Zero Carbon Building Standard, they would have to specifically make sure that they're excluding operational energy, which is different from this document. So there's some things in the document that are quite useful. As I said, these purple boxes are really easy to read. They pop off the page, and it provides a base set of minimum requirements for the things that should be included. Also, something that I really liked in this document was that they have they say when the assessment should take place. So there's a requirement for it to take place at the start of, at the end of the detailed design of design development, and then they also recommend an additional one at the end of the project at substantial completion. So we have like a more final value to use. So one model to help inform the design, and then one to have a final value for what the project actually ended up being. So there's some unique insight like that. This screenshot shows some of the default material properties that are provided, which I think are quite useful as well. You can see on the screen here that they provide examples of percentage of recycled content, for example, for various different material types and uses. So you can see structural steel sections that are showing as a 20% default recycled content, but reinforcing steel is shown as a 97% recycled content. And again, these numbers will obviously vary depending on the market and the country, obviously, but it's still useful to have a point of reference and a place to start if you don't have another better information for your specific market. Some other default information that is useful here, we can see we have default transportation distances by material, which is quite interesting. So you can see here on the first table 7 there, it says things like concrete, aggregate, and earth would be locally manufactured or locally mined, and they give a default distance, kilometers for that. And then if you go up to things like CLT, facade materials, carpets, that would be more on the large scale regional, so in this case European scale, and they provide a default transportation. So again, some useful information. Similarly, there's default values that they provide for recovery rates, recycle rates for different materials. And another list of useful defaults that if people are doing this type of analysis would be a good point of reference is the expected lifespan for various different materials or systems in buildings. So we can see a default of 30 years for roofing coverings or default service life of 20 years for sanitary ware or various other defaults here, which again would vary from place to place, but it's very useful to have a reference point that we can start working from. And this table is obviously very large, and not expecting people to read all the details, but it's across from left to right is the various life cycle stages of a building. From you can see the A1 to C4 and beyond, and that's the level of detail that most projects report, and hopefully that they report one number under each of those life cycle phases. But in this document, they're suggesting that each of those should be reported for each of the individual subsystems of the building, which is interesting. And they have, again, the purple boxes are the ones that are required. So for example, the product and construction phases of the substructure and the superstructure are required, but you can see that the other values are also recommended. So I think this was an interesting way to break down how these results can be reported in a lot higher resolution and a lot smaller, more detail for the decision makers to make use of. So again, that was just a really quick overview. Wanted to bring that to everyone's attention. As I said, it won't be 100% applicable in all markets, but I think it's a really useful point of contact, and there's a lot of other really great information in that document. So I just wanted to bring it to everyone's attention. I will hand it back over to Tina.
Great, thank you so much, Ryan. We are going to head over to Canada now and hear about some work happening over there. Caitlin Gillis is going to join us. She is a well-being and sustainability specialist with Stantec's Sustainability in Buildings Performance team in Edmonton, Alberta. Caitlin's background is in building engineering, deep green architecture, and environmental psychology, which allows her to understand both the social and technical sides of complex problems facing both people and planet.
Thank you, Tina.
All right, Caitlin, and you should be able to share your screen now.
Okay. I seem to be having problems with that. No, I'm not getting the share my screen.
Okay. Well, what we can do, Caitlin, is we can go to Graham and then try to organize it. So maybe I can pull it up.
Okay, thank you.
Okay, so we are going to do a switch and have Graham give our case study. So Graham is a sustainability leader and champion with 15 years of community planning, consulting, and project management experience. He is a specialist in sustainable development issues and green buildings, and is passionate about building better cities through performance-based planning and design. Graham has served as a sustainability lead on more than 30 public and private sector projects and has developed green building strategies and sustainability master plans for clients across Canada and the US. Graham is a Vancouver-based principal with Stantec, where he leads the firm's Canadian practice for sustainable buildings, infrastructure, and communities. All right, Graham, and we can see your screen. Take it away.
Hello, everybody. Thanks, Tina, for the introduction and for the invitation to speak today. So I'm going to try and pull a number of the concepts we've just been talking about this morning together through the lens of a specific project and a case study on that project with respect to performance around materials specifically, and that's the UBC Brock Commons Tall Wood House. A little bit about the project. I want to talk a bit about the UBC policy framework and the context within which this project came from. It's a really unique project. And then a little bit about the performance and then future directions in terms of where we see this precedent taking us. We've introduced me, and the only thing I wanted to say here was just a little bit about Stamtec. We're a Canadian-based global design firm. We operate at every scale of the built environment, and I lead our sustainability building performance team on the Canadian side of the border, which supports better performance outcomes for projects across the built environment through the lens of performance modeling and rating systems and other evaluation tools. The UBC context for this project is important because this is it's a bit of a unicorn project. This wouldn't have happened without a significant degree of leadership from the UBC as an institution and a number of specific individuals at the university. They're a world leader in sustainability. They've very successfully embedded sustainable development principles across their operations, and they've done that through the concept of the living laboratory, where they incorporate research, operational, and academic efforts to leverage specific projects and specific experiences on the campus into scalable and replicable and testable actual projects that can be evaluated and applied to the broader community. And this is a great example of what one of those looks like. That the living lab philosophies had a significant impact on the built environment, in particular at UBC. They've done about $1 billion worth of development in the last 10 years, and much of that has been at the front end of building and infrastructure performance. And I think what's important to recognize about Brock Commons is it Innovation at the scale we've seen on this project is a relatively rare thing in construction. The industry is painfully risk averse, and it's very slow to evolve, especially for those of us in the green building world. And we really don't see big moves like this. There's a real sluggishness in the industry around innovation with respect to performance. It takes a long time, as I'm sure folks on the line know. But the Living Lab construct really provided a bit of an antidote to this inertia by creating an owner-driven mandate and a framework for innovation. And it was their commitment to mass wood construction and all of the barriers to that construction, or removing those barriers that really allowed the project to move ahead. They addressed the code limitations, they addressed supply chain issues, and they addressed the economics of the project specifically in order to make this happen. And I'll talk about those each in turn. I also just want to note that the provincial government of British Columbia requires that all publicly funded buildings certify under the LEED rating system. And UBC has taken that one step further and developed an implementation guide that extracts the most value possible out of that requirement through a specific set of requirements around energy, water, and carbon. And there's a real focus on the latter on material health and on life cycle analysis through the lens of the version 4 version of the rating system. So when you do a project at UBC, the approach to LEED and compliance with LEED is really already determined. There's a very prescriptive set of outcomes that the university is looking for. And in this case, market leadership through a cost-effective and replicable mass timber project was the driver for the project, but reduced environmental footprint through that mass timber construction, energy conservation and reduced carbon emissions, and effective use of water resources were all specific targets. UBC also had a specific energy density target of 120 equivalent kilowatt hours as part of the design. So what does the project actually look like? The project team, I should note, the architect was Acton Austria. It's a local Vancouver-based architect, and the structural engineers were Fast and Epps. So the heavy lifting was really done by those two firms. Stantec and my firm were involved and responsible for the mechanical, fire protection scope, the electrical engineering scope, and the sustainability work. And sustainability in this context was LEED certification, facilitation, and compliance and the strategy around that, and then LCA analysis through the lens of LEED version 4 to evaluate and assess the performance of the building from an overall life cycle perspective. UBC is at the very western end of the peninsula within Metro Vancouver, and is separated from the city by a very large park. There's about 400 acres, a daytime population of 70,000 staff, students, faculty, and 15,000 students living in residence. There's a number of challenges locally because of the geography and the real estate prices in this city. There's a major unmet demand for student housing on campus. And so the champion and the client for this project was the Student Housing Department at UBC. They are the largest student landlord in Canada. They've developed about 3,000 beds in the last 6 or 7 years, and Brock Commons was an addition to that mix, and it's the first building in a new complex in the center of campus that will ultimately hold between 12 and 1,500 students. The building is on a very small site. It sits behind, sort of wedged between a parking garage and two other buildings. 18 stories, 400 and change in terms of units. They're primarily studio and 4-bedroom apartments. It was completed last September in time for the school year and had a budget of about $50 million. And fundamentally, the unique element of the project is it is a mass timber hybrid building. And when it was completed last year, it was the tallest mass timber hybrid building in the world. It will maintain that title for, I think, about another 6 months. There's another mixed-use residential project in Vienna that is hot on the heels of the UBC project, and we'll take that title shortly. Study and social space on the ground floor with student lounge space on the top floor with some of the cheapest and nicest views in Vancouver. So the design. The foundation, the first floor, and the second floor slab, along with the stair and elevator core, are all cast-in-place concrete. And the wood material is used as the structure. So there's no steel in the building of significance. And the wood material was sourced locally from British Columbia and manufactured by Structureland in Penticton. The mass timber construction was really only possible because of a site-specific building code regulation that was granted by the province of BC and facilitated by the university that established requirements for the project to meet or exceed the performance of a comparable non-combustible building. So, long story short, this particular project was only possible in this particular site because of what was effectively a site-specific exemption from the typical building code requirements, which is why the superstructure was allowed to be prefab, cross-laminated timber floor assemblies, and glulam timber columns with some steel connections. The envelope was prefabricated steel stud frame panels with wood laminate cladding. On top of the wood structure was 3 to 4 layers, depending on the floor and the area, of gypsum board. And that was specific to, that had a fire protection function. They were very conservative, as you can imagine, in fire protection, seismic requirements, and acoustical considerations in order to ensure that those issues were addressed and could be studied over time. And the intent is ultimately that the building code will be, in British Columbia, will be updated, or as the building code is updated over time, it will incorporate the experiences and the lessons learned from this project in a manner that allows us to exceed the current code requirements, which are currently 6 stories. So this is a significant departure from what's permitted by current building code. So how does the building actually perform? I'm going to show you a little bit. It's a short video, time-lapse video of the construction process. One of the significant elements of this project was the speed with which it went up. The structure and the envelope were completed about 2 weeks per floor. And the project overall was completed with 2 months left over in the schedule. So the prefabrication and the just-in-time delivery resulted in huge benefits to the construction process, and a number of other downstream advantages. There was a 50 to 60% reduction in construction waste relative to other similar projects at UBC. And those were lead projects that were tracking their construction waste and had a significant diversion rate. So that's a reduction from already high performing and high diversion rate projects. Significant reduction in vehicle traffic on site from construction and deliveries and waste management. And a significant reduction in manpower on site. There was only 9 or 10 trades on site during the construction process, which significantly, again, reduced construction traffic, reduced noise, and dramatically reduced the potential for accidents on site. So from a feasibility and constructability perspective, the outcome was really positive for the university and for the builder. Other speakers have already spoken quite a bit about the V4 framework and life cycle analysis within it, so I'm just going to skip through that and talk about the actual comparison and the analysis of the construction assemblies. So the analysis was based on the proposed building and a baseline, and the baseline took the form of a very similar residence tower that was completed the year before. That was one that Stamtec was also involved in, and it was based on the issued for construction drawings and a bill of materials. And this analysis, to be clear, was completed at the end of construction. So this wasn't a guidance or decision-making tool. This was a retroactive analysis to assess and understand the implications of, again, that big move toward mass timber construction in lieu of concrete and steel. We used the Athena Impact tool, consistent with V4. And as you can see in this table, the foundations were relatively similar, but there are significant differences in the walls, the columns, and the floors. So we had timber columns relative to reinforced concrete in the baseline building, and we had cross-laminated timber flooring relative to reinforced concrete in the baseline building. And the envelope was prefab, steel framed with wood panels versus concrete sandwich panels. So the impact across all of the Athena categories was significant. We were 24, 25% in each one. So not only did we meet the minimum threshold, but we qualified for an additional 2 points and an exemplary performance point. So the overall contribution of the LCA analysis to the LEED strategy and the LEED scorecard was relatively significant. For the baseline building, the reinforced concrete floors contributed the highest to the embodied carbon, followed by the walls, and then by the concrete foundation. For the proposed building, for this building, the floors were the leading reason for the reduced global warming potential. The energy performance target of 120 kilowatt hours per meter squared per year. We're still doing the post-occupancy assessment. The building hasn't been open for a year, but it does appear to be in line with that target, which is it's not terribly aggressive, but it's a relatively well-performing building. The mechanical systems and electrical systems in the building were fairly straightforward. The innovation in this project was really in the structural and the material selection. So where's this taking us? And what can we expect to see in the future with respect to mass timber? I think what's most interesting about this project is the rediscovery of much of what we used to know and used to practice historically with respect to wood and mass timber construction, and how elegantly simple the project actually was. When you drill down and look at the schedule and the assembly and the outcomes, this was a very straightforward project, and has had positive outcomes for virtually every stakeholder. And fundamentally, in North America, wood's almost always a local material. It absorbs and sequesters carbon, and if we can find a means of replacing steel and concrete in future projects, the potential benefit is tremendous. You combine that with a prefabricated construction model that reduces site waste, transportation impacts, and accelerates the schedule. That translates into a very cost-effective construction scenario, which really is the driver for change in this industry. There was a 7% premium on this project over business as usual, what they called the innovation premium. But it appears, based on the analysis, that premium was largely related to upfront first-time costs and would be largely eliminated in subsequent work. So we have and do see this as a commercially viable project and one that is replicable for future applications, providing the building code continues to evolve in a way that allows more substantial use of wood over time. And I will leave it there to wrap up and allow some time for Caitlin and questions at the end. Thanks very much.
Great, thanks so much, Graham. That really brought to life a lot of what we've been talking about, especially with the time video. So in our last few minutes, we will hear from Caitlin, and then we'll ask you all, if you can, to stay on the line from 10 to 10:15 for Q&A. And if you can't, thanks for coming out, and we'll post a recording on online later.
Thanks, Tina. So I can't see the screen for some reason, so I'll just ask you to switch the slides if that's okay.
Okay, sure.
Okay, great. Thank you very much. Apologies for the technical difficulties on my side. Don't really know what's going on, but we'll go with it. So I'm going to give a high-level review of the CAGBC's zero carbon building standard. So next slide. So the zero carbon building standard is really the first standard from Canada to really focus on carbon emissions. And it looks at this both through operations and embodied carbon. It was officially released in May 2017, but there are 16 projects that signed up for the pilot phase, which started in January of 2017. And I'll show you some of the pilot projects later on in this presentation. Next slide. So what they really wanted to do is to focus on carbon as one way to meet the COP21 targets. And instead of just looking at energy performance, it really considers the carbon intensity of the grid as well. Next slide, please. So the standard is applicable for all new and existing building types except Part 9. So for in Canada, that's low-rise residential buildings. And there are two certification pathways. So design, so that's once the design is completed, of course, and then performance. So these are for buildings that have been operational for at least 3 years or 12 months post-occupancy for design certified buildings. And design certified buildings are expected to go for performance certification as well. I think this is really great because the CAGBC notes that 80% of buildings that will be standing in 2030 are currently standing, and 50% of those standing in 2050 are currently standing. So the standard really gives existing buildings an opportunity to make significant changes, and we know how important that is, and for new buildings to really start off on the right path. Next slide, please. So there are 7 sections of the standard, which you can see on the screen, and as this is the embodied carbon network, I'm going to focus briefly on section 7, embodied carbon. Next slide, please. So pretty typical in the approach, it looks at cradle to grave analysis, and it considers structural and envelope components very similar to LEED. Next slide, please. So there are currently no performance targets.
Sorry, Tina, we can't see the slides. If you're able to, I don't think anyone's being able to see the slides.
Okay, give me one moment. Sorry, I'll just give me one moment. Okay, can you see them now?
Yes, we can see your screen now.
Okay, apologies.
Great, thank you, Ryan. Okay, so there are currently no performance targets. So this is relatively new metric in Canada and elsewhere. So it's really about gathering data right now. And of course, it's CO2 equivalent is how it's reported. And many different LCA programs can be used. Typically, we use Athena in Canada and Tally is used in the US. Next slide, please. So for the pilot projects, as I mentioned earlier, there are 16 that registered for the pilot phase. It was really great because they spanned across Canada. So you had all the way from Nova Scotia on the Atlantic side of the country, all the way to British Columbia on the Pacific side. And they included new and existing buildings. So in total, there are projects in 6 provinces. Here's just a list of all the projects that signed up. I know this will be circulated later. So as you can see, there's one project in Alberta, Manitoba, Nova Scotia, and Quebec, and there are several in Ontario and British Columbia. Next slide, please. So Stamtec has been involved with 2 of these projects. So the one in Nova Scotia and the Evolve 1 project in Waterloo, Ontario. So next slide, please. Evolve 1 in Ontario was the first project to receive the zero carbon building design certification, and that just happened in April. So I wanted to briefly touch upon similar systems globally. So what other world green building councils globally are doing. So the World Green Building Council has a project called Advancing Net Zero. There are currently 15 green building councils around the world that are part of this project. And of those 15, 5 so far have created zero carbon building standards. And 3 of them, so the French, Canadian, and the Australian, have somewhat included embodied carbon. And the other 2, so from Brazil and South Africa, plan on incorporating embodied carbon in future iterations. Other green building councils globally may be doing other things as well with regards to embodied carbon, such as the UK Green Building Council has released a practical guidance report on this topic as well. So I know that these slides will be circulated, so I just wanted to have some resources up if anyone's interested in learning more about the CAGBC standard or the World Green Building Council's project. Thank you.
Great, thank you so much, Caitlin, and apologies all for the technical difficulties. Thank you to our other speakers, Kate, Ryan, Megan, and Graham for joining us today. We've had several questions come through, so I'm going to open up for a question and answer. So thank you all for coming today, and just a few updates before we go into that. I just wanted to remind everyone that we will have webinars throughout the year. So our next one will be on June 15th, and the materials focus group will be leading that. So I'll include more information on how you can get involved in that. Okay, so if our speakers could just be unmuted and ready for Q&A, we'll get started. Okay, so this first question is for Kate. Excellent argument on ozone depletion potential. Are these 5 impact categories predetermined by LEED? And is there a scope for other impact categories to be included?
Oh, that's really interesting. Yeah, so there are, at the time when the LEED version 4 credit came out, those were the standard LCA impact categories being reported in LCA tools and data sets. Those are the life cycle impacts that have the highest global consensus around methodologies for calculating them. So carbon and global warming potential has the highest global alignment, and it is a global impact. There are the new standards coming out for environmental product declarations have increased the number of impacts and ways in which impacts will be reported. But they're not explicitly saying removing any of them. And there are other researchers who are proposing alternate environmental impacts. The key comes to when is there large enough global consensus on a methodology to report environmental impacts, and when they come forward. The most noticeable difference in the upcoming ISO standards is related to biogenic carbon reporting. So we should expect more data on carbon emissions related to biogenic materials and biogenic fuels.
Great, thank you, Kate. And so our next question is for Megan. And someone asked, please provide more details around strategies around participating in operational energy savings.
Okay, so let me just preface, I was not part of this specific strategy, so if I don't answer your question, please shoot me an email and I can get you more information. But in general, the main kind of gist of this strategy is it basically provides the reader with some guidance on how to, if you want to participate in operational energy savings as part of your comparative whole building LCA, you can. I guess you just have to make sure that if you're including operational energy in your design proposed building, you also have to include it in your reference building. So it does kind of provide you some guidance there. It's mainly, the main takeaway is that if you're, for example, if for your structure, if you're including more material to have more thermal mass, you need to take into account that added material, even though it's technically not, required for the structural performance of your building. you need to take into account those materials, but you should be able to see hopefully an offset in the impact when you're including the operational energy portion. I think the other example that's referenced in the document is also, if we're taking into account things like thermal bridging and making sure that you're accounting for the added material, embodied impacts from the added material, but also being able to take, hopefully offset that by the operational energy savings that you can show. So there's a lot more information in the actual chapter. But yeah, like I said, if I didn't answer your question, please shoot me an email.
Great, thank you, Megan. And our next question, it was posed to all of our speakers, so I'll let you all, go ahead and answer. So is whole building environmental product declaration, EPD, a possibility?
I'll start.
Right.
Anything's possible. So if you wanted a whole building environmental product declaration, one presumes that what you want to have is comparable results from whole building LCAs and a way of publicly declaring the results. So you would require a couple of things. You would require a product category rule, so the standard method of accounting. You would require aligned data sets of environmental impacts, and as well as a lot of the information that's in the RICS practice guide in terms of standardized methods of material replacement rates and such. And then if you conduct a whole building LCA following that standard and reported the results for an environmental product declaration for a building, you would be then assuming that there would be a third-party review to confirm that you met that criteria. So it, the question would be, what is the end goal? And I think many of us have the goal that we would have comparable whole building life cycle assessments. And so a lot of that work is, I think, underway in different organizations to standardize the methodology of whole building life cycle assessment. And we need better standardized whole building life cycle assessment upstream data. And I think we're moving in that direction. We need more funding to support that.
Yeah, this is Ryan speaking. I wanted to echo that that what we're seeing actually in a lot of the European countries that are more developed on this topic is that they've done just what Kate has mentioned, is they've standardized a methodology that is the required way to calculate these, things. And they've also standardized a national database of LCA-based data to use for the assessment. So the problem right now in North America is that there is too many options, really. You can use Athena, or you can use Tally, or you can use another software, and then where are you getting your data from, and what are the rules that go into that? So obviously on one side, it's good to have options and to have so that the market have multiple ways that they can assess this information. But as Kate says, that does make it very difficult for to compare results from one project to another, because they likely use a different software, they likely use a different data set and all of that. So, but I would recommend, if anyone's interested in learning more about that, you can look into some of the European national efforts. And actually, my firm ZeroStrategy did a detailed policy analysis in summarizing those European approaches. You can find that on our website at publications.zerostrategy.com. Or if you just Google it, you should be able to find it, or actually just send me an email. That's probably the easiest way.
Hi, this is Caitlin. The Wood Innovation Design Center in Prince George is actually one of the first projects in North America to look at this. I can send the link around, Tina, if you want to share it, because I have a really good case study on it.
Yeah, definitely. I'll make sure everyone gets it.
Okay.
Hi, everyone. This is Graham. The Athena Institute, in conjunction with UBC, actually did do a building level declaration for Brock. It isn't yet a public document, but they have committed to wrapping that up within the next few weeks, and it will be posted. So I'm happy to send a link out to that. But there are, to Ryan's comment, it's interesting. Stamtec did an LCA via Athena. Athena has done its own environmental building declaration level assessment, and UBC has done its own performance overview report, and they're very challenging to compare. They're even with the same data, same project, the assumptions and the inputs are quite different, and so the conclusions, while in general terms are similar, you'd be very challenged to use any of them as a effective decision-making tool at the front end of the project at this stage.
Great, thank you, Graham. And we have one more question that we'll end on here, and I imagine several of our speakers will be able to provide some answers here. But somebody wanted to know, they mentioned, it's great to see guidance coming out of the United Kingdom. What are some of the embodied carbon developments taking place recently in North America? And we have talked about some today, but are there any others that you all would like to add?
Well, I'd like to highlight the Structural Engineers 2050 Commitment Initiative. There's been a group of structural engineers through the Carbon Leadership Forum and the Structural Engineers Institute working to advance a challenge for structural engineers to report material quantities and then translate that to embodied carbon emissions. And I think that aligned with proposals from the Athena Institute for a material quantity database and standardized work, and some other aligned projects are really positive for the potential of moving North American practice forward.
It's Graham here. I think what I would add to that is we've seen through LEED, similar to what we saw with low VOC materials 10 years ago, and how LEED helped transform the supply chain and the broader market around that topic. We are now seeing, because of the significant contribution to the LEED scorecard that an LCA can provide, we're doing that as a matter of course on most of our projects now. And while the industry hasn't quite caught up in terms of what I would consider a high degree of literacy around this subject yet, we are I think at the beginning of a phase in which it's becoming a stronger part of routine project analysis. So we're a ways away from using it as a decision-making tool for most projects, but we're starting to understand the implications as a result of the LCA tool through LEED, which is an important step in that direction.
Yeah, this is Ryan, just chiming in on that. How I often describe this to my clients is that this is where energy modeling was 10 years ago. At 10 years ago when LEED started, really was one of the first standards that really introduced and started pushing the market in terms of energy modeling. These were the exact same discussions that were being had. Are these numbers comparable? What's the methodology? How are we doing it? And it's not going to overnight. We're not going to answer all those questions, but these are the discussions that help get us to that space. So I'd say, don't discount it just because it's not perfect yet. It's definitely on the way to being a really valuable tool, but it's likely going to be a few years down the road.
Great. Well, thank you again to all of our speakers for volunteering your time today and giving this great informative session. We will make this recording available if you missed any part. And I will add to that last question that the Carbon Leadership Forum has been working really hard on a carbon smart building initiative over the last year, and we'll be hosting an event in New York City this summer. So if you're there for the AIA conference, we invite you to learn more about this Carbon Smart Building initiative and to be part of the discussion. So again, I'll send out a link to this event and its details along with everything else that was mentioned today. And it's good to mention too that the Embodied Carbon Network is a really good platform to share these types of things. So any documents or guides, we have a forum where you can just quickly share it and share links and spread the word. So I encourage you all to get engaged and to let us know of anything that you are aware of out there. So thank you all, and we will see you next month for the materials webinar.